Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P. For company A, there is a 60% chance that no claim is made during the coming year. If one or more claims are made, the total claim amount is normally distributed with mean 10,000 and standard deviation 2,000. For company B, there is a 70% chance that no claim is made during the coming year. If one or more claims are made, the total claim amount is normally distributed with mean 9,000 and standard deviation 2,000. Assume that the total claim amounts of the two companies are independent. What is the probability that in the coming year, company B's total claim amount will exceed company A's total claim amount? Because some students ask me when they saw this problem, let me explain that companies A and B make the claims. They do not receive them. They are not insurance companies. Let A be the event that company A makes a claim and B the event that company B makes a claim. Let X sub A be the expense paid to company A given that the event A happens, and XB be the expense paid to company B given that the event B happens. Note that while it is theoretically possible that the normal distributions considered produce negative values, we disregard that possibility as its probability is so close to zero as to not affect any calculations. Using the assumption of independence of claim amounts of the two companies, we write that a probability a company B claim exceeds a company A claim amount is the probability that complement of A happened and B happened, so that B produced a claim and A didn't, or or the event A and event B happened and XA is less than XB, so both companies produce claims and a claim produced by A is less than a claim produced by B. These are two mutually exclusive outcomes, so we can write this as probability of A complement intersection B plus probability of A intersection B, and XA is less than XB. And again, due to independence, that's probability of A complement times probability of B times probability of A plus probability of A times probability of B times probability that XA is less than XB. Then that's 0.60 times 0.70 plus 0.40 times 0.30 times probability that XA is less than XB, so it's equal to 0.18 plus 0.12 times the probability that XA is less than XB. This random variable XB minus XA is a linear combination of independent normal random variables. Therefore, it is a normal random variable with mean equal to the difference of the two means, so it's negative 1,000. Its mean is 9,000 minus 10,000, negative 1,000 equals negative 1,000. And variance equal to the sum of the variances of X and XB. Remember that the variance of a sum of or a difference of two independent random variables is the same and equal to the sum of their variances. The minus sign makes no difference in this case. And standard deviation is the square root of the sum of the two variances, so it's the square root of 2,000 squared plus 2,000 squared, which is 2,000 times square root of 2. Let us write z for a standard normal random variable and phi for the cumulative distribution function of it. We are looking for the probability of xb minus xa is greater than 0. That's the same as probability of xb minus xa minus its mean, which is negative 1,000, divided by its standard deviation, which is 2,000 times square root of 2, is greater than 0 minus negative 1,000, which is 1,000, divided by 2,000 square root of 2, So we just do the same operation on the right-hand side of 0 as we did on the left-hand side. That's the same as property that z is more than 1000 over 2000 square roots of 2. We write z for the left-hand side of the previous inequality because that is the left-hand side is a normal random variable standardized. And so it becomes a standard normal random variable for which we write z. So this is the same as property that z is more than 1 over 2 square roots of 2. And that's the same as 1 minus the property that z is less than or equal to 1 over 2 square roots of 2, which is approximately 1 minus the property that z is less than or equal to 0.3536. That's equal to 1 minus phi of 0.536. And we don't have that reading exactly in the table. The closest value in the table is 0.35, but I use interpolation between 0.35 and 0.36. Use the values from the table. Now, of course, on the test you will have a standard normal and variable calculator, so you may use that. But as a result, we get approximately 1 minus 0.6382, and that difference is equal to 0.3618. Okay, so given that, we can plug that into the calculation that we already did before, and what we're looking for is 0.18 plus 0.12 times the value we just calculated, which is 0.3618, and the result is approximately 0.2234, which is answer D. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.